Well, greetings all. Joseph Kursky here. My colleague Kansarina Kurnia is with us all the way from Asia for this particular monthly higher education Esri chat. So glad that you're here with us. We do these every month, and as a reminder, we will talk about this later on, but we're going to have one right after New Year's as well. But today, we're so excited about this. We've been looking forward to this for weeks because we've got Patrick Ryan and Brady Ross. Now, these two folks are extremely knowledgeable. They're really good instructors. They really know their stuff, and they're really nice people. So they're going to talk about ArcGIS Arcade. And this is in part in response to what you all have been telling us that you would like to see in these higher education chats. So keep those suggestions coming, because we really want to serve the community and have these good discussions every month about tools, methods, how to teach with these tools, etc. So we've got Patrick and Brady here. Welcome to you both. They're solutions engineers over here at Esri. I think they're neither one of them are in Southern California, but they're kind of spread out, just like our education team is. But really glad to have you both here. Also, we're probably going to mute everyone. And here, Kansarina is showing us the January chat, as I mentioned a moment ago. Just make some sort of digital or pencil or some sort of notes to yourself, because it is going to be the first basically working day after New Year's for many of you. So please don't forget about this, because it's another really good session that we've been looking forward to for quite a few weeks. Spatial stats tools and what's new with them. We've got a couple of folks on our spatial statistics team. Probably some of you have seen them in the Esri user conference plenaries in the past. So again, just like the folks today, Patrick and Brady, they're great instructors. They're very knowledgeable, and we're really looking forward to it. We'd love to have you there in January. So please join us. All right, Patrick and Brady, we're going to turn it over to you, fine folks. Thanks again for doing this.
Awesome. Thank you so much, Joseph and Kansarina. And good morning, good afternoon, everyone else. I'm Brady Ross, and joining me is Patrick Ryan. We're on the Federal Sciences and Civilian team with the federal government under the national kind of government umbrella here. We're both located on the East Coast. I'm near Vienna, Virginia, and Patrick's over in Loudoun County. But yeah, I guess since this is a higher education team, I got my undergraduate at South Dakota State University, so I kind of enjoyed the NDSU conversation earlier. And then I got my master's in geography at Cal State, LA. But yeah, then I moved East Coast and started here as a solution engineer. But today we're here to get to know ArcGIS Arcade and how we can leverage it across various applications. So there we go. I just kind of want to go over a quick agenda, kind of so you guys can know what to expect throughout this presentation. First, I want to level set kind of what is ArcGIS Arcade for everyone. I know some of you probably have experience already with Arcade and using it in your maps, dashboards, and apps, but some of you might not. So I kind of just want to make the play field equal for you all and just make sure we all kind of understand what it is at the basic levels. Then I'm going to dive into the profiles, expressions, and workflows, how to create an expression, what you can kind of expect within an Arcade profile, and how to kind of look through our documentation and understand the documentation that's available to you all. And then we're just going to look at some expression basics. So understanding whether Arcade is case sensitive or what mathematical operators are allowable in Arcade. Some of those kind of just basic understandings of Arcade as a structured language. And then we're going to have some demos for you. I'm going to be showing Arcade in web maps, specifically focusing in visualization, labeling, and pop-ups. And then Patrick will show an extensive use case scenario in ArcGIS dashboards. Like, it's pretty exciting to see what he's capable of building up there. So let's go ahead and start. So like I said, most of you have, maybe some of you have experience in Arcade, maybe some of you don't, but really the question is, what is ArcGIS Arcade? When you Google it and find our documentation, this is a description here. ArcGIS Arcade is a portable, lightweight, and secure expression language written for use in ArcGIS. So what does that mean? When we say portable, it means we can write, share, and execute expressions across ArcGIS. This means I can create a simple Arcade script in ArcGIS Pro, copy that same script, translate it to a web map or a dashboard. And then without changing any of the code, it should work. I'm able to translate my arcade that I've written across multiple applications. There's going to be a little bit of variance looking at profiles, which we'll see in a few slides ahead. But for the most part, you can translate and reuse your arcade across anywhere in ArcGIS. It's lightweight. It means that there's going to be no libraries or DLLs to install. It comes with your ArcGIS Pro. It comes with your ArcMaps and online cloud environments or your enterprise environments. And it's built into dashboards and your mobile applications with custom JavaScript APIs. So it's already there within the ArcGIS understanding, and you can already use Arcade within all of those factors there. And it's secure. So it means there's really no executable code that anybody can come and steal or harm anything or really be a threatening menace with kind of hacking into a Python or an R workplace. It's really secure in our own environment. It only executes when it's being used. And when it's being used, it's typically just labeling a feature in a map, or it's generating a text for a pop-up, or checking attribute in a geometry fashion for whether you have valid geometry or invalid geometry within your data there. What it cannot do, since I think it's also nice to understand what Arcade cannot do, is it can't really run analyses or automate a task. You're not really going to have those high-end statistical analyses with Arcade. We're going to be it really only runs in specific, well-documented situations, which we'll see with our profiles. And it's an expression language. So if you're familiar with how JavaScript is written, it's going to be pretty familiar or similar to that. But with the expression language, it provides values used for rendering these features, or it can check feature classes in the geodatabase for valid or invalid attribute data, or you could even format your data to represent rounded numbers or trimmed values, or even show data in a dashboard's element with data expressions. And then it's also just for use in ArcGIS, meaning it's developed by Esri for Esri. So it's developed by Esri for ArcGIS. Arcade is written to help you make better maps, build better interactive apps, and to provide better, higher quality data. It makes the data easier to understand to those looking at your maps and apps and dashboards. And while it's not going to replace what you build in Model Builder or automate with Python, it will be a way to better interact with your audience and make it easier for them to understand the data you're really meaning to give to them. So I keep talking about these profiles and why they're maybe important. And really, when we look at this, the simplest way I like to think about a profile is what I expect as an output. So there's about 12 to 15 profiles out there. And really, when I want to look at the documentation, I'm thinking about what I want to build with my arcade. I want to think about the output. So do I want a pop-up? Do I want to customize my visualization or my labeling? There's a different profile for each of these features. And each of these profiles have kind of different input and output variables that you can put into your code here. So some profiles are very generic and usable in more than one part of ArcGIS, like labeling, pop-up, and visualization. Those are pretty versatile across all our software. Others might be more specific. So our dashboard and attribute rules profiles might be more specific to dashboard and attribute rules. And we'll see some examples of that with Ryan's demo here. And then each profile also comes with global variables. So our global variables are really what's going to be the input to our expressions, to our arcade that we're writing. This could come from a data store. It could be a feature in a map. It could be even a layer in a map. It could be the map itself. It really depends on what profile you're using. And then your global variables will be available to use depending on the profile you use. But again, it's really just the output that you want in the end. It's going to be the quick and easy way to understand what a profile is. So let's go ahead and just kind of break down a simple arcade expression here. To kind of build up a scenario, imagine we have some weather station data, and we want to, for each station point on a map, we want to show the station name, we want to show the temperature and the humidity at the time. So when we're writing arcade, we delineate every variable with a var right at the beginning. So we have var label, and then we're going to trim our feature station name. So trim is a function, and then our variable is going to be our feature.station name. And then what trim does is really, if there's any excess spaces before and after our station name in our attribute table, you're just going to get rid of those extra spaces. So we just really have the clean string text format of the station name. Then an operator of adding with a plus sign there, and then adding a constant, so it's the text formatting dot new line. So that's really just going to be like a return or an enter on a keyword. It's going to give it a new line, make our output label pretty easy to understand. Adding another operator with round, and then our feature dot temperature. So this is going to round our temperature to the nearest whole number. That 0 delineates where we want to round to, and so we want to round to the nearest whole integer right there. We're adding a literal of our degrees Fahrenheit, then giving it another new line, and then really just printing the percent humidity there, and then adding another literal percent RH. What this will give us is this map right here. So we're looking at the Colorado area. We have the name of our station name, the temperature, and then our percent humidity. And then, like I said, since it's transferable across ArcGIS, we could copy this, put this into a web map, or save it there, and then it can be transferred to kind of wherever else we need to have the same visualization for labeling. So like many of the tasks you perform using ArcGIS, there's a pattern or workflow you can use when building an Arcade expression as well. What you need to do is determine the profile you will use. For example, labeling, pop-ups, or visualization. And then the profile really identifies the context where the Arcade expression is evaluated and understood. The profile also determines the global variables available to use in your expression. And then the global variables provide the data for the expression. So that's where you're going to be able to look at your feature, your data store, your layers, or even if you're maybe more specific to view scales, you can have your global variables set at view scales. And then really the Arcade language, it provides the tools for building the expression in way of variables and data structures. There's conditional statements, looping structures, there's mathematical, logical, and string operators. There's even user-defined functions, so you can build your own functions and then perform those functions on your maps. And it's a comprehensive collection of functions you can use to manipulate the data. And then at the end, the expression, when evaluated, returns the result you need. So let's look at how this might look like in actual code. Here we're looking at different examples of codes and different lines. That's just some really kind of basics for the Arcade language. First, it's case insensitive. You don't really need to care about whether you're capitalizing or not capitalizing variables or labels like that. It doesn't really care about that. And then as for comments, you can have 2 forward slashes to have a single line comment, or you can have a /* for a multi-line comment, and then you'll end that with a */. There's multi-line statements. So if your lines or if your code's going to kind of extend beyond one single line, there is multi-line statements. And then what you're going to do is at the end of that multi-line statement, you just end it with a semicolon to tell Arcade, this is where that one statement ends, and we're going to continue on, or just as a return, just return our value we expect. And then, like I said earlier, you declare all your variables with var. So var direction here is going to be your wind direction. You can access feature attributes using these global variables. You can even access join data. So if you have joined attachments from a survey 1, 2, 3, where you have image attachments, or if you have joined tables, you can access those joined tables and really expand upon the quality of what data you have accessible within a map. Then you can access features in a layer, and even return explicit results with the return statement. So if you have multiple lines and multiple codes running in your Arcade expression, Arcade is going to return the very last one that it runs. So, but if that's not what you want to return in your final return statement, you're going to have to specify a return option here to give you kind of whatever you really need. And that means it's going to be an explicit return. So to understand Arcade, it really functions pretty much the same as any other Python or R or any other coding language. We have arrays, we have Booleans, we have access to date and dictionaries, and then numbers and text. But within ArcGIS, we kind of can go beyond that. Arcade also understands attachments and features sets. We'll be building some feature sets in the data expression with Ryan in the future. So it's kind of exciting to see that you can build feature sets. You can build feature set collections, so collections of feature sets within your data. And maybe one of the most important is that you can also understand, Arcade also understands geometry. So if you have intersects or buffers or overlapping features, Arcade's going to understand that geometry, and you'll be able to delineate those kind of specific scenarios within a kind of whatever profile you're using. And then if you're also in an enterprise environment, it's the same for portal environments and ArcGIS Online environments. And then as for mathematical operators, it's pretty the same as well. There's addition, subtraction, multiplication, division. You can increment, and you can always compare. And then there's also logical, which is the and ors with the ampersand and the two vertical lines. And then there's also built-in functions, which you may already have experience with, but they're all there with sort, whether you're looking at if the value is empty or not. Now we'll return the date and time of the current time that the code is executed. And like I said, it also works with intersects, means, trims, etc. And there's a lot more options for these built-in functions. This is kind of just a subset of what I chose to show off here. And then there's also conditional statements and for loops and if-else statements, and then also your user-defined functions. So you can always build these out for a bit more complex scenarios and see how these might play out in your own maps. With that, I'm going to go ahead and jump into my demo here using Arcade in a web map. So here we're kind of jumping into the new map viewer for ArcGIS Online. And what we're currently looking at is the total acres in 1630 of forest land in a state. But this map can be misleading because really what we expect from this map is that Texas and California has all the trees. And we really don't see Vermont as the Green Mountain State in the Northeast. So a better way to really visualize this, this map might be to show us the percent coverage rather than the total acres. So if I actually look at the attribute table, and if I scroll all the way to the right, we can see these values are in their whole numbers, and they don't really show us any percent coverage field at all. So maybe we can use Arcade to build that for us. And that's exactly what we're going to do. So if I look at this layer, I can go to the styles and the percent coverage. We can see a really single line statement here is using to convert all those fields into a percent coverage. So we're taking the field of 1630, dividing it by the total areas of land, multiplying it to get from acres or from square meters to acres, multiplying it by 100 to get a percentage, and then we're rounding it off to the nearest whole number with this 0. And as you can see here in the Arcade expression editor, we have a list of all our globals available. So this is going to be all our field names that we can choose from. Similarly, all our functions that are going to be available within this profile that we're looking at. Since I'm in a visualization statement, do note that attachment's not available, and it's going to tell us we don't have access within this profile to use attachments. But let's, for example, just look at what we have for round. So here's our round, and I can press this I, and we can see kind of how to build out this round if we aren't familiar with maybe what we need. And we can see that expects the value, and then a comma and a number of places to round to. So that's exactly what we built out here. All right, and so then I'm going to just turn off the original layer and then visualize by this percent forest coverage. And we can see that this story for this map is actually changing quite a lot. We now see states on the East Coast have a bit more of that forest coverage rather than the total acres. And then Texas and California lose their dominance within this map. So we have a bit more accurate map now to talk about the history of forests and the percent coverage change of forests within the United States. Another kind of cool trick I'll just show off quickly is if we look here in the Upper Peninsula, we don't see really the outline of the current states correctly, at least. And what we can do there is look at the base map, and we can change this human geography and then go to the detail part of the reference and just reduce the transparency to 0. And we can see that the outline of those states now are going to become a bit more visible, a bit more normal to what we're used to seeing. Not arcade related, just a nice trick right there. The second example I want to show you is working with some of EPA's environmental justice data. So this is data available through their website, and it's really robust, although it might be kind of hard to understand just looking at the table. Here we are looking at lead paint across the United States, and then if we look into the attribute data and the fields we can visualize from, we can see there's quite a lot. There's about 11 other variables to choose from: ozone, particulate matter. But if we're able to draw one or two of these, we're going to get a pretty dense map of data and information to show off. It's not going to be very pleasing to the eye or very easy to understand. So instead, what we're going to do is we're going to count up each of these variables if they meet a minimum threshold, such as 80, a value of 80, and then show that map to show the count of how many of these variables are over this threshold. So maybe we can identify which block groups might need more attention for specific attention for environmental justice concerns. So to do that, I can go to the styles, I can build up another expression, and I'll just talk through this expression that we've already built out here. So first, you can see we're commenting out the first line of double lines here. We're accessing all the fields that are necessary in this expression. So we're just saying, within this arcade expression, here's the fields we're going to be using, easy access. Then we're going to be building an array of these fields, and we're starting a variable total counts equal to 0. Within that, we're doing a for loop for x in our array. We're seeing if that value is empty. If it is empty, we're just going to ignore it and continue. However, if the value is greater than or equal to 80 and is not empty, meaning this exclamation point is not, we're going to give that total count equal a +1. And what that returns is, if I do a test, we're going to have a result of 0. And our messages, we're going to see kind of test examples of what values we might be expecting to see. So it looks like it's functioning correct. If I turn on the values for this, I'm going to zoom into a certain area so rendering doesn't take long. We can start to see areas that might be a bit more specific to our environmental justice concerns. Maybe once it starts rendering, it'll show a little bit more cleanly here. Oh, that's because I'm in the wrong layer. There we go. So here's the areas now where we're looking at the counts of these 11 indicators, and maybe we can start seeing which block groups might be more significant for EPA and funding to send funding to. These areas of this dark red are going to be where 9 to 11 of these variables are at that 80% threshold or higher, whereas areas in this kind of peach color are going to be where only 1 or 2 areas are. So this gives us a lot more thorough understanding of where block groups are kind of being more affected by environmental justice according to these 11 EPA indicators. With that, I'm going to pass it over to my colleague Patrick, and he'll go into some ArcGIS dashboards configurations here.
Great. Thank you, Brady. Hello, everyone. Let me share my screen. Again, my name is Patrick Ryan. I'm a solution engineer on the national government team. And just to follow in Brady's footsteps, I have my BA and MA from George Washington University in geography. And little fun fact, GW is the only school in the nation's capital with the geography department. So again, I'm going to dive into some ways you can leverage Arcade in your dashboards. I'm going to stop my video here just to make sure I have enough bandwidth and get started with my slides. So the new dashboards, as you all are very well aware of, moved to general availability with the April 2021 release of ArcGIS Online. What was Dashboards Beta is now referred to as Dashboards, and the old operations dashboard has been renamed Dashboards Classic. The most important difference between the two is that the new dashboards is built on the ArcGIS API for JavaScript 4.x. And this allows the new dashboards to make full use of the web map capabilities and ultimately to provide better performance. To be certain, you will see a more consistent design between what was configured in the web map and what is presented in the dashboard. Some other important differences, supported data sources now include CSV layers and feature collections. There's new configuration options for number patterns. The relative date filter allows you to query events within the last week, month, quarter, or year. There's some new statistic types. There's a new capability with selection-based display. It's an option where elements only render when a selection is made elsewhere in the dashboard. And URL parameters have a new structure. And this is an important one that I'll come back to again at the end. And Arcade is now supported in dashboards. So for instance, Arcade expressions written in the web map are now honored in the pop-ups in details elements when they weren't previously. And there are now 2 new profiles specific to dashboards. You can use Arcade expressions for advanced formatting of the list and indicator elements to customize how your data points render. A data point can represent either a feature or summary statistic based on how that element is configured. Advanced formatting allows you to make visually compelling and informative elements for your dashboard. Formatting expressions returns a dictionary based on a key value pair. And depending on the element, the set of dictionary keys are different. You can configure custom attributes and reference those attributes when configuring the element, even in the HTML editor, as we'll see. Advanced formatting uses the dashboard formatting Arcade profile. Data expressions are Arcade expressions written to return a feature set. The returned feature set is then used as the data source for one or more of the dashboard elements. By leveraging Arcade's ability to perform mathematical calculations, to manipulate text, evaluate logical statements, and so on, they offer dashboard authors a whole new set of capabilities for configuring informative and robust data visualizations. Dashboard element backed by a data expression can participate in the full dashboard interactive experience. Data expressions can help prepare your data for use in a dashboard and in turn, allow you to unlock new insights by combining, modeling, or enhancing existing data, or even to leverage data that you do not own from the Living Atlas, for example. And it's important to remember that a data expression must return a feature set. And data expressions use the dashboard data Arcade profile. So with that, let's jump into our demonstration. So I'd like to start in this web map and discuss an important concept that Brady mentioned in his slides, and that is the idea of a feature set. As the name suggests, a feature set is just a set of features, and what it allows us to do is to leverage other data layers in our web map, in our organization, or even, again, the Living Atlas. So here in our web map, we can see we have just 2 layers, USGS seismic data and USA states layer. So leveraging feature sets, what I'm able to do is to interrogate a state, let's pick on Wyoming here, and it will query the USGS seismic data layer. So here we can see that we have 12 earthquakes in the state in the last 30 days, and the largest had a magnitude of 1.9. And this was located about 22 Ks south-southwest of Mammoth. So let's take a look and to see how we've done this. So coming into our pop-up configuration, when my internet catches up with me here, we can go into the expression manager. And we can see that we have 2 Arcade expressions written. So the first one, we're returning just the count of earthquakes. And so again, what we're doing is leveraging the feature set function where we're calling the USGS seismic data layer. And this is one of our globals. So as Brady mentioned, the global variables will depend on the profile that we're leveraging. So feature sets are not available in all profiles. They are in the pop-up profile, which we're doing here. And I simply got to it in the map layer and called the feature set by name, which it then populated here. I'm then passing that feature set into a group of chained functions. First, we want to determine those USGS earthquakes that intersects the feature of interest, Wyoming in our example, and then we're going to return a count of those. Similarly, with the other expression that we have here, we are calling a feature set the USGS seismic data. We're only looking at those that intersect our feature of interest, again, Wyoming in our case. We're also going to get a count of those features, which you'll see why here in a moment. We're declaring some empty variables here to populate our result. And then we want to use a series of conditionals. So if we have earthquakes in our state, we want to use a for loop to iterate through them to determine what the largest earthquake was and its location. And then we take those variables that we just declared here, populate it in a result statement. If we don't have any earthquakes in the state, we trigger the else clause, and we have our return built there. So two very simple explanations, but let's take this and see how we can bring this into a dashboard. So straight from our web map, we're going to jump in and create a dashboard. And when this creates, what we'll see again with Wyoming, that arcade expression in our pop-up is honored. Let's take another look at how we can leverage arcade in our dashboard. So I'm going to add a list element here, and we'll build this out together. So you can see when I add an element, I have three different choices for the data source. We can pick layers from our web map, we can pick layers from our organization, or we can author a data expression, which we'll do here in a future example. But for this one, we're just going to look at our seismic data layer. So for this, I'd like to sort these by magnitude. We'll look at those descending, and then we'll move over to our list tab and start building this out. So I think we'll start out and be looking at the event time, I believe it is. And we'll add another line item here, and we'll look at the magnitude. And then we'll jump down and do one more, and we'll pick the place of the earthquake. So here we have a list sorted by the strongest earthquakes down to the least. And I think rather than using a symbol in our list here, what I'd like to do is leverage advanced formatting to highlight those earthquakes with a 7 magnitude or greater. So here in our advanced formatting, we will enable it, and you'll be presented with an arcade expression window here. You can see for our global variables, we have a list of all of the different attributes within our layer. And for this, again, what I want to do is to highlight those earthquakes with a 7 or more magnitude. So we're going to declare a variable called color. I'm going to go to our functions, and I think for this one, an if F statement is going to be what we'll use. And so if we pull it into our expression builder from the function reference here, we're told what parameters it's looking for. So our conditional expression, this we're going to want to tell it that if the magnitude is greater than or equal to 7, we want to return a value. And I think for this, what we'll do is we'll return a value of pink. And if it's not true, what we'll do is just return a blank. And so what we need to do then is take this variable we've just created, and we're going to use it in our return dictionary here. So we'll just say color. We'll exit out of here, and you can see now that we've done this. Our earthquakes with the 7 or greater magnitude are highlighted in a pink color. You may notice this last pink line and the first white line, we have earthquakes that appear to be of the same magnitude, but one is pink and the other is not. This highlights another great use case for arcade within dashboards to format our variables. So let's create another variable. We'll call it magnitude. And I will go to our globals and I will pull that in. And what I want to do is use the round function, which you saw Brady use earlier. And I'm going to round that to 1 decimal place so that we don't have this rounding area that I believe is causing our issue here. In order to leverage this, we're going to need to uncomment our attributes. So we'll go ahead and do that here. And we'll pass attribute 1 the magnitude variable. So we declared it, we formatted it, and now we're passing it to our return statement. And so now down here in our line item template, what we can do is we can add that by saying expression and then the attribute name, in this case, attribute 1. So we will write this out. And you will notice very quickly that it was a rounding error that was causing the discrepancy here. So with using advanced formatting, I was quickly able to highlight some lines of interest, to format my attributes, and add a list element. So let's jump in and take this example a step further. So here is that similar earthquake dashboard, just fancied up a bit more. And would like to start on the right side here with our list element again. So we'll jump into our configuration. You'll see that the layer we're referencing again is that USGS seismic data layer. And in our list, what we've done is taking some of those initial concepts a step further. So we're declaring a variable color again. This time we're using a when statement because we have various different returns. So when a earthquake is less than a magnitude 4, we're going to return this hex color, and so on and so forth as we'd like. Brady mentioned the ability to create our own functions. So that's what we're doing here. We've created a function that when we pass it the number of seconds, we're going to format the elapsed time. And we do that down here. So our first variable, we're determining the date difference between now and the event time in seconds. We're then passing this second since event variable into the function that we've defined up here. And then we're going to use that in our return statement. So in a return statement, you'll notice that we have several different attributes that we've declared here and returned. So let's jump out back to our line item template to see how we've been able to leverage those. So here you can see we're passing it the expression value, which we've declared here, the header also declared up here. But what we've also done is leverage some of these attributes within our HTML code. So here in our HTML editor, you'll notice that we have some style references for color that we're declaring. So not only can you format and use advanced formatting to populate items in your line item template, you can also use them within your HTML editor, as we've done here. Another great way to leverage Arcade is with data expressions, and we're going to do that with the serial charts on the bottom. I'm going to start on the bottom left with a serial chart that is configured like you've done many in the past, I'm certain. We're filtering our seismic data to look at only those earthquakes within the last 72 hours. We're parsing that event time by the hour. And then we're using a split by field to look at event type, which you just see defined up here in our legend. So these are the types of seismic activity that we have, and these are stacked bar charts. So nothing fancy here, just a standard bar chart. But let's say we wanted a bar chart with an attribute that's not within our data table. Like, for instance, looking at earthquakes by the day of week. In this case, what we need to leverage is a data expression. And you can see that our layer, our data source here is this group by DOW for day of week. We're going to come in here and look at how this was created. So I wanted to highlight feature sets, not only because they're a really powerful way to really create some informative pop-ups. It's also how you're going to need to create your data expression. So data expressions are going to be created with a feature set by portal item. I'm referencing ArcGIS Online, so the portal is represented with the variable P. Item ID is for that seismic USGS data. And then we're going to group that data by the event time. So we're using a group by function. And again, we're going to return a count of the magnitude is just a field that it's going to count over, and it's going to group those by the event time. Then we need to take that feature service and bring it into a dictionary to be able to iterate on it. So we're going to create a blank dictionary to start with, an index that we can iterate through, and then a for loop where we're going to run through and we're going to populate the number of seismic events by the day of the week. As I mentioned earlier, data expressions need to be returned as a feature set. And so that's what we're going to do here at the end. We're going to convert that dictionary back to a feature set before returning it again as a group by to calculate the number of earthquakes by day. And what we see here. And the third example on this dashboard I'd like to highlight is how to use Arcade in a series of conditional expressions to populate an indicator element. So let's come into our indicator element here. And you'll see that we're leveraging that USGS seismic data layer. We're going to have our data point is going to look at those earthquakes that are less than 24 hours old. We're just getting a count of object IDs, and here we see 229 earthquakes in the last 24 hours. We're then also going to turn on our reference variable. And for this, we're going to filter our data to look at those earthquakes that are greater than 24 hours old, but less than 48, so the day previous. And again, we're just returning a count of object IDs. Over in the indicator, what we've done is calculated the percent change between those two data points. I'd like to highlight something that Brady mentioned several times in his presentation. The global variables are dependent on the profile that you're using. So you'll notice here, we only have two global variables that we can access, that data point and the reference variable that we declared to begin with. The list element had all of the different attributes. Indicators are very different in that case. And another, I guess, important point to highlight here is the power of Arcade to quickly iterate through your data to really understand it and to gain insight. So we've declared two variables for some criteria that are going to determine significant changes in earthquakes. So we have a series of conditional expressions here. We have an if statement. So if our percent change is less than that first threshold, we'll return one dictionary. If it's greater than the first threshold, but less than the second, we'll return another. And then we have a third if it's an extreme increase. And since we haven't had a dramatic change in earthquakes in the last 2 days, let me just show you how you can quickly iterate through this. So you'll see that I changed our threshold to a different value, and it's returning a different result. So that really highlights the power of Arcade to iterate through your data to really gain more insight with it. So I'd like to maybe take this and step back to another dashboard here and really try to hammer home some of the ways that you can leverage Arcade in a maybe a bit more simpler example here. So here we're looking at a dashboard for the state of Maryland of water monitoring stations. On the list, or on the left, we have a list of those stations. It's one list item per station. But let's say we wanted to visualize this or to examine it, summarized by county. And we can leverage Arcade, as you see here on the list on the right, to do just that. So let's jump in to see how this list was configured. So again, we are leveraging a data expression for this, and we'll jump into the editor to see how this was done. So I'd like to maybe point out a couple things. You may have noticed on my previous example, when I called a feature set by portal ID, I passed in different variables. So I had declared a variable for where that portal is. I had declared a variable for our item ID. This 0 is indicative of the index for our feature. So it's index 0. In the brackets here, these are all the fields that we're returning, and the star represents just that. We're returning all fields. I didn't point it out earlier, but you also need to declare whether or not you wanted to return the geometry with this feature set that we're calling. So my previous examples were set to false. Here we're setting it to true, and you'll see why here in a moment. We are, again, grouping by county, and then we're creating just some summary statistics, right? The count of station numbers, the average rainfall, the average water temp, and then the count of advisories. Here are the different variable names that we're giving them in this feature set here. So we'll cancel out of here, and I'll come over to our list element and show you in the globals now. Our global variables are populated with the attributes that we just declared in that group by function. So we have the county name, the average rainfall, water temp, the count of advisories, and the total sites. And you'll notice our geometry is also returned. Down here in our light item template, very similar to the last example, where we're able to call, highlight these here, some of those expressions that we declared here in our return statement. And again, we're doing the same in our HTML editor. So we can come down here and you can see our attribute 2 is our advisory color. And this is just using an HTML color style tag to color the advisories green if there are none, and red if there are one or more. And the reason I wanted to highlight the use of our geometry here is these list elements are interactive now. So because I'm pulling the geometry in, this list can act as a filter to set actions for our web map in this case. So pretty powerful stuff here. Let me jump back in to my slide deck and just really want to point you to some great resources that you all can leverage when you're learning and deploying Arcade in your work. So as Brady mentioned, our documentation is very robust. So I encourage you to take a look at it and be familiar with it. We've got a great GitHub repository. Oh, sorry about that. That you can come and find some Arcade expressions. That day of week expression that I shared with you, I actually leveraged one of the Arcade expressions here to my use case. There's a great blog post by a colleague of Brady and I's, Lisa Berry on the Living Atlas team, Your Arcade Questions Answered. She continuously updates this blog as new questions come in, so I highly recommend you take a look at it. The product page for dashboards is full of great resources as well, including a gallery of existing dashboards that might give you inspiration for your work. And what I wanted to point out, as I mentioned at the beginning, there's a new URL structure, and you can make a copy of a publicly available dashboard by inserting this new #ID equals before the item ID to create a copy of any publicly available dashboard. So you can go in and see how the elements were configured yourself. And let me show you really quickly how this was done. So you'll notice the organization that I've created this in is our Esri Federal org. And I'm pretty sure that none of you are a member of this. So what you would need to do in this case is to delete the Esri Federal.maps, as I've done here. So it's just arcgis.com/apps/dashboards/ that new number ID equals. And if you hit the go on this, what it's going to do is kick you out to a create new dashboard page. So you can create your own copy of this dashboard and again, explore how the elements were configured for yourself.
You might have saved the best for last there, Patrick. That's awesome.
Pretty cool, right? And just last thing, and we'll make all of this available to you. There's a lot of great blogs out there, in addition to the one I pointed out, specific to dashboards, and just a sampling of some of those for you to take a look at. So appreciate your time and your interest. And with that, we'll open it up to questions.
Many thanks, Patrick and Brady. I told these folks that you two were extremely knowledgeable and great instructors at the same time, which is a great combination, and you definitely proved my statement. There is one question that I'm pretty sure I knew the answer of, but just running by you, you talked about case sensitivity. Someone was asking if $feature capital wind speed is the same as $feature lowercase wind speed. I'm pretty sure that's the case, and it's just a convention that we use caps for the field names, but I just wanted to run that by you.
Yeah, that is correct. Case sensitivity doesn't really matter for functions or variables, so you can mix and match those case sensitives in those ones as well.
And
but
another
for readability, people generally use the caps for the. Plus, if you pick it from the list, it puts it in caps automatically. Yeah,
that would be
exactly
my recommendation. Pick it from the list.
Thanks. Yeah, excellent. You know, that whole replicability, copyability thing is so important in education and probably in other sectors, but it seems like especially in education. So that last piece that you showed about being able to copy that dashboard and expand it for your own needs. Wow, that's really powerful.
Yes. So there is a setting. It's on by default, but in the item details page under settings, you can turn it off so that that ability is not there. But by default, it is on. So that was why I had an asterisk next to that. So unless somebody's turned it off, you can save a copy like that. And for all my examples.
Okay, much appreciated. Do you have that written down as a short blog essay or something like that in case someone missed that and wants to review it like I do? That capability, or just put it in the chat box maybe?
It's in my slides. We'll make these available. I
Perfect.
Don't believe I've seen a blog post on this.
The slides is fine. Yeah, thanks so much. Corey's asking, this may have been covered, but will there be arcade functionality within GeoBIM applications, or does that currently exist? And Corey hasn't perhaps dove in far enough. GeoBIM arcade functionality. I don't know the answer to that at all.
I don't either.
Okay, we'll get back to you, Corey. Maybe one of the community members knows.
How about the question from Danny Smith? Have you been answered? How do you continue the expression after a written value is calculated, and also use the calculated written value as a variable later in the expression, if that makes sense?
Yeah, Danny did have a comment that he understood that, but or she, but perhaps that's a good thing to ask anyway. Even if Danny understands that, I'd like to have a little expansion of that too.
Yeah, I think I understand what is being asked here. So I'll go ahead and share my screen quickly.
Thanks. Yeah, that's a really powerful thing to be able to do.
Yeah. So yeah, and what you want to do is you want to assign a variable then to your statement. So with this first example, looking at the %4s, I really just gave it a variable percent equals to the rounded values, and then I could return that percent variable here. However, if I were able to make a variable of a return statement and test it, I get this error, this unexpected token return. So what I think the workaround then would be to do is you could comment that out, and you can make a variable of using that that original variable minus a random number. So I'm taking my percent minus 90, and then you could just return this last statement. So you can use that within a variable equation, and then it'll just return that variable as a kind of a new step. And then you can test, and then it'll give you an actual result. So you have to like break it down into another step to return your return statement.
The console function would be very powerful here too, to see what different variables are. If you've got a long script, you could use the console function to do this. Brady, I think you had an example with.
I
with
yeah,
that.
I do. So going to my EPA indicators, we can look at this here quickly. So yeah, going back to this, we're counting the number of variables that are above a certain threshold, such as 80%. And if you notice through my for statement, I have these console statements used. And what this will do is it'll output a value at this location as it's going through the for loop. So I can kind of test as it's running this for statement. So go ahead and test. And as I'm running through these, this for loop and running it in this messages tab, it'll actually use this console function to output what kind of expected results at this step in the for loop am I expected to return. And so you can always use console and then a variable name to kind of say, hey, well, it's making progress, it's checking, and I'm getting accurate results. And then it'll just keep going. It's kind of just like a print statement for our Python.
Super. Kind of building on what you're talking about, oftentimes we get these questions from faculty, and we've had discussions over various conferences over the last year or two about, how do I get my students dipping toes into the waters of coding? And I think Arcade is a perfect way to do that, right? Because it's sort of immediate gratification. It, as you explained at the beginning, no libraries, all kinds of tech advantages, and you can do some powerful things with it. And it gets them thinking about how a GIS thinks, how a computer thinks, just gradual dipping toes into the waters. I really like it for that reason as well.
Yeah, that's definitely a good point. It has that instant gratification, and it's a lot of the fun stuff with GIS. You're dealing a lot with the pop-ups, the visualizations, and it's not like the back-end Python stuff that you might not be able to see. So it's fun to use and easy to dive into.
Indeed. Hey, Chris is asking, okay, ArcGIS Online is often leading in advances in tools compared to Portal, maybe Enterprise. Anyway, currently, are there any abilities that we can't do in the most current Portal/Enterprise?
Related to Arcade, right?
Related to Arcade, yeah.
That is often the case. So for instance, feature sets were a capability that came about in Enterprise 10.7.1. So if your enterprise is before that, you won't be able to leverage feature sets. There is in the documentation a list of what the newer functions and capabilities are, and they're when they'll be available within enterprise.
Great, many thanks. We've got, sadly, I knew this would happen. It's like we barely get rolling and it's time to quit already, but as these fine colleagues of ours have explained, folks, there's no shortage of documentation on this. From the, hey, I want to start with a 1 or 2 line expression all the way to these multi-line expressions, really building a lot of power in. There's no shortage of documentation, but also lessons that use these, and on the Learned Lesson Library and elsewhere, the documentation sometimes is actually a good mini lesson in itself, like from you all, from Lisa Berry and others. So just wanted to make sure that people knew that there are ways to keep moving forward with this. All right, folks. Gosh, sadly, we're going to need to close it off there. However, thanks, Brady and Patrick. It was grand and glorious and a lot of fun to have you on our higher education chat, and reminding folks that right after New Year's, we will have our next one on spatial statistics for January, Tuesday, Jan 4. So please come back and we'll have more fun next month. In the meantime, I wish you all a very spatial new year.